Hey everyone, today we're going to be performing a thermal radiation experiment. Thermal radiation is a form of energy that is emitted by atoms when their electrons change from one state to another. So if you can imagine, when an electron jumps from a higher energy state to a lower energy state, it's going to emit some form of energy to go down that energy state. So when that happens, it generates electromagnetic waves, and electromagnetic waves can be used to emit heat or thermal energy. So we're going to get a little bit closer and take a look in just a second. So what we have here is a very straightforward setup for measuring the amount of energy, the amount of radiation that can be emitted by this object over here in the middle. We're going to have this heat source generate some form of heat which is going to be transferred to this object, and once this object absorbs that heat, it's going to radiate it outwards, which is going to be measured by this radiometer on the back. We have a very straightforward very simple thermocouple connected over here, which is going to be measuring the temperature of this, and we're going to be using the ambient temperature and using the ambient temperature and the temperature of this plate to estimate how much radiation this object is supposed to be radiating. This is in compliance with the Stephen-Boltzmann law, which states that the amount of energy radiated by an object is proportional to the difference between the ambient temperature and the heat source temperature to the power of 4. So this instrument right here is what's collecting our data. We're interested in two things. First is the temperature of that plate that we're measuring with the thermocouple, and then also the amount of thermal radiation that the radiometer is absorbing. Upon taking a closer look, we can see what I was talking about. According to our experimental guidelines, this black plate is supposed to be positioned 50 millimeters from the heat source, and the radiometer is supposed to be positioned 110 millimeters from our heat source. So there are two parts of this experiment. In the first part, we're going to be measuring the amount of energy radiated by this black plate, but then in the second part, we're going to be comparing how much energy is radiated by a different object. In this case, we have a polished plate. So in order to perform the experiment, we're going to start out by placing this black plate in the 50 millimeter marker and taking note of the ambient temperature, which in our case is 23 degrees Celsius. Then we're going to crank the power to maximum over here in order to generate heat and to heat up the black plate. So we're going to start off by taking the radiometer, the thermal radiation measurement when it starts off at 40 degrees Celsius. When it was at 40 degrees Celsius just now, I believe the radiometer reading read 9. So we're going to take measurement of that. And then at every increment of 10 degrees Celsius, we're going to measure the amount of thermal radiation until we reach 140 degrees Celsius. So at this point, we're going to make our final measurement. So at 140 degrees Celsius, our radiometer reads at 147 watts per meter square. So for the second part of this experiment, we're going to be measuring the emissivity of the other plate. Emissivity is simply defined as the ratio between an object's ability to radiate heat as compared to a black body. So in our first part, we had a black body, but in this part we have a polished silver plate. So we're going to try and measure the emissivity of the silver plate. So we're going to start off by powering our system. We remember that our ambient temperature in the last part was 23 degrees Celsius, so it should be about the same in this experiment. We're just going to let the reading settle, and then we're going to make our measurements. Alright, so in this part we can vary the temperature at different rates. So I would like to just start off by making measurements at 29 degrees Celsius. Your the data set provided to you could take measurements at different temperatures. It doesn't really matter as long as there's a wide range. So to get different ratings for this part, we are just going to slowly vary the power source bit by bit to see how it makes a difference on the radiometer reading, and what temperature. The important thing to note is what temperature the plate is at while we take that reading. Well, I hope you guys learned how this experiment is performed and what it's all about. If you have any questions, you can reach out to me through Dr. Nashrul. For the results and discussion part, you can calculate the theoretical values, and then compare them against our experimental data. Any discrepancies, try and anticipate what are the sources of error. A few hints for that would be the ambient, the surrounding, and what kind of an effect that could have on the experimental data. Well, thank you for watching and all the best.